Dear students, hope you enjoy learning Python. In our previous modules, we learnt Python control structures and data structures such as list, tuples, dictionary. By using these constructs, you may be able to write extremely simple programs, but everything beyond simple program will likely use functions eventually. Are you wondering why functions are a keystone of so many programming languages? So, why is it useful for programmers to divide programs into separate functions? Why not write every program as one big chunk of statements? Let us look into the reasons why they are so important and what they do for us. Functions are a suitable way to divide your code into useful blocks, allowing us to order our code, make it more readable and reuse it whenever needed. For example, suppose you would like to write a calculator program. You can write every logic in a separate function. For instance, one for addition, one for subtraction, etc. A function can be called many times as and when needed. To simply put, a function is a group of code that performs a specific task. Functions may also be called as subroutines or procedures, etc. Once you decide to use a function, you put code in it just like you would place code in a program. By giving the function a name and defining parameters it should accept, you can pass information to the function and return some result. Functions are reusable. So, once you write a function, you can call it anywhere else in the program. The program which calls a function is a calling program and also called as caller, and the function itself is said to be called program or function or also called as callee. So, functions are useful, but what purpose do they serve? Let us see a few of them. First, functions encapsulate tasks. Functions can also be called black boxes because we do not need to know how they work. That is, when you invoke a function, you really do not need to care what exactly the code inside it. You just need it to know how to invoke it. Suppose you have a function that calculates the square root of a number. It is just enough if you know how to invoke functions by its name, input to be given and the output to be returned. Secondly, functions separate tasks. They also allow us to cleanly divide their code into various segments. Then, functions let us reuse code. There may be situations where you write some code to perform a task and you will use it more than once in your program. Copying and pasting the needed code into multiple places is not a good programming practice. Not only does it add complexity to your program, but it is amenable to introduce places for something to go wrong. If you change something in the original block, you need to repaste it in all places. Functions eliminate these problems. They make it easy to reuse code whenever we want in the program. Once you have defined a function, you can invoke it anytime. If there is a change to be done, it is just enough to do changes in the function alone. Now, let us turn our attention into the advantages of functions. Functions enable code reusability. They let us develop an application in modules. Functions are easy to debug. They reduce lengthy code, that is, no need to write lot of code. Shall we go through the steps to writing a function? In order to write a function, first understand the purpose of the function. Then define the input that comes into the function from the calling program. that is the input to the function is given as parameters. Next, identify what variables are needed inside the function to accomplish its purpose. Then, determine the set of steps that the function will use to accomplish its purpose. And finally, find the result, that is the output to be returned from the function to the calling program. Hope you have understood the need for function and the steps for defining functions. Before digging further, let us understand what are arguments or parameters with respect to use of functions. Information or input from a calling program can be passed to function as parameters or arguments. Parameters are specified after the function name inside the parenthesis. You can have as many parameters as you need based on the requirements of the function, but separate them with comma. Now, let us see how to define and use functions in Python. Functions can be of two types, namely built-in functions and user-defined functions. Python has a number of built-in functions that you have already come across. For instance, print, which will print an object to the console; int, which will convert an argument into an integer data type; dict is used to create a dictionary; range is used to create a range of numbers; type to find the type of object passed. We have been using these built-in functions since we started learning Python. So, let us focus on defining user-defined functions. You can define functions which provide the required functionality. Here comes the simple steps to define a function in Python. A function block begins with the keyword def followed by the function name and open and close parenthesis. Any input parameters or arguments should be placed within these parentheses, but parameters are optional. The code block within every function starts with colon and it is intended. The first statement of a function can be an optional statement, that is the documentation string of the function or docstring, which we have already discussed when we were discussing about comments and indentation in one of our earlier modules. The statement written with expression exits the function optionally, passing back a result to the calling program. A return statement with no argument is same as return none. Have a look on the syntax for defining a function. Here you can see the syntax for defining a function. Line 1 in the syntax tells the name of the function followed by optional parameters and finally a colon. The colon indicates the beginning of the function block. Line 2 is the docstring which says the purpose of the function, it is optional. Line 3 and further lines are the statements that solve the purpose of the function. The last line in the function is the return statement. It is used to return a value from a function. Return statement without an expression returns none. If you do not want to return anything from a function, you can omit the return statement. It is an optional statement. Please do remember that when function returns a value, it must be received in a variable or in an object in the calling program. Got the syntax of defining a function? Okay, let us start with classic Hello Python script using function. Open Python ideally and create a new text file, save it as hello.py. Now we will define the function. A function is defined by using def keyword followed by name of your choice followed by a set of parentheses which hold any parameters the function will take, but there can be no parameters and ending with a colon. In this case, we will define a function named hello. See the console for the definition of hello.py. So, here what you can see is definition of say hello function. The first line is having df keyword, which says the beginning of the function definition, followed by name of the function having no parameters, ending with colon. Then the first line of the function is the docstring, which says what the function is doing. Then followed that we have a print statement which just print hello students, and finally we have a return statement which returns nothing. Now we have a function. What to do next? By and large, a function definition itself does not execute the function body. This gets executed only when the function is called. So, we need a calling program or caller for the function. That is, we have to invoke the function from a calling program or script. Defining a function only gives it name, specify the parameters that are to be included in the function and the block of code. In order to execute it, you need to call it from another function or directly from the Python interpreter. So, how to call? Generally, how do we call a person? Yes, of course by name. Similarly, we have to call the function by name only. See over the console for calling the function. So, this here you can see the say hello function is defined. We are calling it from the calling script by using its name. As the function does not take any argument, we are not passing any argument to the function. In the previous example, we had a simple function without any arguments. Now, let us pass some arguments to the function and see what happens. So, here we use the function called print name, but this time we pass some arguments. Here in this example, when invoking the function print name, we pass a string object Anand. This is an actual argument that is passed by the calling program to the called function. In the function definition, we use an argument called name, which is also called as formal argument. When we pass a value from the caller, it is copied into the arguments in the called function. So, here in first call, the string object Anand is copied into the name argument and gets printed inside the function. During the second call, the string object John is passed and copied into name argument in the called function and gets printed in the function. Let us now see how to use return statement in a function. Here we have a function which calculates area of a square. So, we have defined a function having the name area with argument side. So, inside the function we calculate the area by multiplying side twice, and we are returning the calculated area to the calling program. See how you can invoke the function now. In the calling script, first we read the side, then we pass that side as argument to the area function. Now, control passes to area function wherein area is calculated and it is returned to the calling program in the variable r, and that return value is printed in the calling script. Functions can be more complicated than say hello or print name functions, which we have just now defined. For example, we can use looping structure or more within a function block. Let us try one such example. Try to write a function that finds the factorial of a given number. So, here what you see is the function which calculates the factorial of a given number. So, the argument is passed from the calling script to the called factorial function, wherein we calculate the factorial using a for control structure. The calculated factorial is returned to the main function, and in the main function we are printing the factorial. Can you try writing functions for the problems shown on the console by yourself? Have you tried? Find comfortable with writing functions? Okay, then generally in most of the programming languages, the parameters can be passed to a function by two mechanisms, namely pass by value and pass by reference. Rightly speaking, Python uses a mechanism known as call by object, sometimes also called call by object reference or call by sharing. That is, object references are passed by values. If we pass arguments of type immutable objects like integers, strings or tuples to a function, the passing mechanism is like call by value. The object reference is passed to the function parameters. They cannot be changed within the function, that is, they are immutable. If you change the value of the parameter, they are created as a new object with new ID only. First, let us have a look at integer objects. The parameter inside of the function remains a reference to the arguments variable as long as the parameter is not changed. As soon as a new value is assigned, Python creates a separate local variable. The variable in the caller will not be changed. See an example for this. So, here we have a function called pass by value which takes an argument. In the calling script, we have an integer object having value 100. Before calling the function, we are trying to print the value of a and the corresponding ID. Then we call the function by passing the value of a, and inside the function again we print the value of a and its corresponding ID. After returning from the function, we are trying to print the value of a and ID of a. You can see the output on the screen now. Here a is passed by value to the function and a is an immutable object. Here same example is modified in such a way that inside the function the value of a is changed to 200. So, as we have seen earlier, when you assign a new value to the variable a inside the function, it is created as a separate object. So, for that program the output is shown on the screen. So, in the calling script the value of a is 100 with an ID. Before changing the value of a inside the function, the ID and the value remains the same. Once we assign a new value to a, it is created as a new object. So, we can see a new value to a and ID is also different. Again, when you return back from the function to the calling script, the original value of a and ID is retained. This means that Python initially behaved like call by reference, but as soon as we change the value of the variable inside the function, Python switches to call by value, that is, object references are passed by value. For clear understanding, please see the console. What you are seeing is a diagrammatic explanation for pass by value. So, initially a value is 100 in the calling program, that is in caller, and in the called program again the value of a remains the same as we are not changing the value of a. Again, when coming back to the main function, value of a is retained. But here inside the function we change the value of a to 200, that means a new integer object is created. So, which changes the value of a and also the ID as we have seen earlier. But when you come back from the function to the main, the original value of a and ID is retained. But if we pass mutable arguments, the behavior is different. They are also passed by object reference, but they can be changed in place in the function. If we pass a list which is a mutable object to a function, there are two cases to be considered. Case 1 is if we pass a list as argument to a function and if its elements are changed in place inside the function, then the list will be changed even in the calling program. Case 2 is if we pass a list as an argument to a function and a new list of element is assigned to it, the old list in the calling program will not be affected. That is, the list in the caller scope will remain untouched. Let us consider these two cases and write examples. So, in the calling function, we have a list having the value 1, 2, 3, 4, 5. Before calling the function, we are printing the value of the list and we are passing the list as an argument to a function. Inside the function, we are printing the value of the list which is received as argument, and you can see a statement a plus is equal to 6789, which will append. Instead of giving a plus, you can also give a dot append of 6, whatever it is. Here the list is getting appended with new elements. So, after changing the value of a, again we are printing the value inside the function. Function to the main program, main script, wherein we are again printing the value of a. You can see the output of the previous program. As the list is appended inside the function in place, the value of a is also changed in the calling script also. This is what passed by reference. Here you can see the same example what we have written earlier, but instead of appending with the list, we are assigning new list of element to a. So, this will create a new object rather than changing the already existing object. You can see the output. Now, I think you can understand what is the difference. Therefore, if we pass a mutable objects like list to a function, we have to consider two cases. Elements of the list can be changed in place, that is, the list will be changed even in the caller scope. If a new list is assigned to the name, the old list will not be affected, that is, the list in the caller scope will remain untouched. This is true for all mutable objects. If you are not still clear, we will reiterate. If the value passed in a function is immutable, the function does not modify the caller's variable. If the value is mutable, the function may modify the caller's variable in place depending on the two cases which we saw just now. See the script over the console and find the output. Here this example is similar to what we have written earlier, but instead of the same object name is used as an argument, here we have changed it to A1. So, even though it is changed as A1, it is the formal argument of A. So, whenever there is a change in A1, which will also change the value of A in the calling script. So, here in the calling script, we are passing three objects, one immutable and two mutable objects. Before calling the change function, we are printing the values of these three objects. Then we call the change function, which takes three arguments a, b, c, which are received in three formal arguments n1, n2, n3, and n1 is assigned to a new value 100 inside the function, and n2 is getting appended by 2, and n3 a new list is added. Then we are printing the values of these variables inside the function. You can see the output of the previous function. So, before calling, a will be 5, b will be 1 list, and c will be list having 2. Values inside the function would be n1 is changed to 100, n2 a new list with the list 1, 2 is appended, and n3 a new list is created. After calling change in the main, a is still having 5, but b changed to 1, 2 from 1, and c is assigned with new list. I hope you can understand why we get these results. In all the previous examples, you would have noticed that in some cases the name of the actual arguments and formal arguments are same and are different in some cases. Looking strange? Whether the name of actual and formal arguments are same or different, then there is no effect. The changes in the formal arguments do not affect the actual arguments in the caller program, but this may vary for mutable objects as we have discussed. Next, we will discuss about the scope of the variables. The variables in a program may not be accessible at all locations in that program. This depends on where you have declared a variable. The scope of a variable determines the portion of the program where the variables can be accessed. Python supports two basic scopes of variables, namely global variables and local variables. So, what is a local variable? Variables that are defined inside a function body have a local scope and called as local variables, and those defined outside the function are called global variables and have a global scope. This means that local variables can be accessed only inside the functions in which they are declared, whereas global variables can be accessed throughout the function body by all functions. The variables inside a function are brought into the scope when the function is called. So, here you can see a function called scope having a variable sum1 with local scope. So, this sum1 variable is used to find sum of 10 numbers in the range 0 to 9. When the same variable is being tried outside the function, we are getting an error because sum1 is in the local scope, which is valid only within the scope function. Here we have defined sum1 as a global variable. It is having a global scope so that it can be accessible throughout the entire program. But still we are getting value of sum is 0. Can you guess why it is so? See, even though sum1 is defined as a global scope variable, inside the function definition we have another variable sum1. This sum1 is not given a global scope, it is given a local scope. So, whose value will be valid only within the function definition. Once you come out of the function, this sum1 is considered the variable having the global scope whose value is 0. That is why you are getting 0 as the answer. So, what was the problem with the previous example? Even though sum1 was declared as a global variable, it was not accessible. Sum1 was declared inside the function also, so it has overwritten the global scope. So, now we use a keyword global to state that sum1 is a global variable. So, once you have added the keyword global sum1, it takes global scope so that its value are accessible across the entire program. So, now when you print the value of sum1 in the calling function, you get the correct answer. Okay. What is next? Hope you can now write functions if you are given some programs. We can call a function with or without arguments as it is defined. So far, we saw how to include number of formal arguments that match with the number of actual arguments in the calling program. But there are other options for including the arguments. They are required arguments, keyword arguments, default arguments, variable length arguments. We will discuss about these arguments in the next module. To summarize, function is a block of code that performs actions within a program, helping to make our code reusable and modular. We have focused on defining user-defined functions in Python. Hope you enjoyed learning functions in Python. Thank you. See you again in another module.